This is section 7.2, which is matrix algebra. We're going to talk about matrices, matrix addition and subtraction, matrix multiplication, identity and inverse matrices, determinant of a square matrix, and applications. So a matrix has what we call an order, so m by n, so is going to be read with m rows and n columns. And you could also see with using the I and the J notation, so the shorthand notation for a matrix, you might also see it written like that. You'll notice here, like this is A1, 1, so row 1, column 1. This would be a row, so this is our term for row 1, column 2. So that's not a 12. That 1 represents the row and the 2 represents the column. So some matrix vocabulary. So each element or entry of the matrix uses double subscript notation. That's the IJ. The row is the first subscript I. The column subscript is J. So the element IJ is the ith row and the jth column. So we're going to look at an example here. So what's the order of the following matrix? We have 2 rows and 3 columns. So this would be a 2 by 3 matrix. Okay, so matrix addition and matrix subtraction. So in order to add or subtract matrices, they need to be the same order. And basically you're just going to take each element in each matrix and either add or subtract them. So for instance, we have these 2 matrices that we're adding together. So our resulting matrix would be 1 plus 2. So it'd be 3, 5, 7, 9, 11, 13. So again, you're taking the 1 plus the 2 to get the 3. You're taking the 4 plus the 5 to get the 9, and so on. So you're adding or subtracting, you just add or subtract each element. Okay, scalar multiplication. So if you have a scalar that you're multiplying your matrix by, you're just multiplying each element in the matrix by that scalar number. So this would become 3, 6, 9, 12, 15, 18. Okay, the zero matrix consists entirely of zeros. So any dimension matrix that has entirely zeros we call the zero matrix. The additive inverse. So be careful here. Those 2 words are going together. We're not talking about inverses right now. We're just talking about the additive inverse. So if you have a matrix that's the additive inverse, then adding that is going to result in the zero matrix. So if A and B are additive inverses, then they would add to 0. It's kind of like saying 2 plus negative 2 equals 0, but on the scale of a matrix. Okay, so matrix multiplication is a little bit more complicated than just addition or subtraction. So you're going to, the important thing is if you have 2 matrices, not all matrices can be multiplied. And they don't need to have the same order, but the column of the first matrix needs to be the same as the rows of the second matrix. So if you have matrix A that has m by r, and matrix B is r by n, notice how those are the same? So that means that your matrix where you multiply them would be dimensions m by n. So that's coming from here and here. Okay, so we are going to find the product of AB if possible. So this is a 2 by 3 matrix, and this is a 3 by 2 matrix. So that means that, yes, we can multiply them, and our result is going to be a 2 by 2 matrix, okay, because again, the 3's are the same. So we're going to end up with a 2 by 2 matrix. So what you're going to do, let's see if I have enough space here to... Okay, so you're going to multiply the row of the first matrix by the column of the second matrix, and you're going to add all of your multiplications together. So for example, I'm going to start with this row by this column. So, and that's going to go right here. So we would say 1 times 1 plus 2 times 2 plus 3 times 0. Then, let me use a different color. To get this term right here, we're going to take the second row times the first column. So this would be 0 times 1 plus 1 times 2 plus negative 1 times 0. Okay, now keep going with different colors. To find this one right here, so I'm not going to be able to write it out, but to find that one, we're going to take the top row by the second column. Okay, and then to find this element right there, we're going to take the second row by the second column. Oops. Okay, so then we simplify, and we're going to end up with, so 1 plus 4, so that first term would be 5. Down here it would be 2. Okay, then we would have negative 1 and 2. So you can see our 2 by 3 multiplied by our 3 by 2 ended up as a 2 by 2. Okay. So an identity matrix is a matrix that has 1s along the diagonal and 0s everywhere else. So you can see we have the dots to show that this can be any size, okay? But the identity matrix is going to have 1s along the diagonal just right there. Okay, so the inverse. So now we're not talking about the additive inverse, we're just talking about the inverse. So the inverse of a square matrix, if you multiply, so if you have A times its inverse, it's going to equal to the inverse times A, which is going to result in the identity matrix. Okay? So also, we're going to write the inverse. So if you're talking about matrix A, you would write the inverse as A to the negative 1. Okay, so finding the inverse of a 2 by 2 matrix. So we're going to talk a minute what this is right here. So AD minus BC is called the determinant, and we'll talk about that in a second. Okay, but finding the inverse of a 2 by 2 matrix. So you can see that our symbol right there showing we're finding the inverse of this matrix, A, B, C, D. We would take 1 over what we call the determinant, AD minus BC, and then you'll notice the matrix is rearranged here. So A and D swapped locations, and B and C are the opposite version or opposite sign of what they originally were. Okay, so the determinant of a square matrix, you're going to see it written as DET A, or kind of looks like absolute value signs of A. So that's the symbol for determinant. It's the sum of the entries in any row or column multiplied by their respective cofactors. This is kind of example written out. So what we're going to do is we will find the 2 by 2 determinants by hand. This book has us finding anything bigger using the calculator. So I made another video talking about how you can either use Desmos with the matrix or your graphing calculator to find the determinant. Okay, so inverses of n by n matrix only if the determinant does not equal 0. So a matrix has an inverse only if the determinant is not 0. Okay, so we're going to find the inverse. So first of all, I could find the determinant. So I could do AD minus BC to make sure it does not equal 0 so that I know there is an inverse here. So this would be 5 times 3 minus 8 times 1. So that'd be 15 minus 8, which is 7. Okay, that does not equal 0, so that means that yes, there is an inverse. So the inverse we would find, so the inverse would be 1 over 7 times, so we're going to switch the A and the D, so the 3 would go there, the 5 would go there, and then the 1 and the 8 are both going to become negative. So that would mean the inverse matrix of A would be 3/7, -1/7, -8/7, 5/7. Okay. So the final thing is properties of matrices. So commutative property with addition, but multiplication not the case, because like the example we saw, if we had a 2×3 multiplied by something like a 3×4, if you switch the order, then those middle two dimensions are not the same, and so you wouldn't be able to multiply the matrices. Okay, you can see associative property, identity property, then we have inverse property and distributive property. So if I did not write these in the notes, but I did include them in the video, so if you want to pause them around, you can. But it's more just being aware how we can add, subtract, and multiply matrices. Okay?